Students, today we will learn Maxwell's third equation, which is also known as Faraday Law of Electromagnetic Induction. Let us consider a closed path inside which there is a bounded surface S. As we know, the number of magnetic lines of force passing through the bounded surface S is the magnitude of magnetic flux linked with the bounded surface. The magnitude of magnetic flux linked with the bounded surface can change in three ways. The first way is if we can increase or if we can decrease the area of the bounded surface. The second way is if we can orient the bounded surface with respect to the direction of the magnetic field. The third is if we can change the strength of the applied magnetic field by either bringing the magnet closer to the bounded surface or taking it farther from the bounded surface. As the magnetic flux linked with the bounded surface changes with time, an induced EMF is generated along the closed path enclosing the surface. The magnitude of this induced EMF is equal to time rate of change of magnetic flux. The direction of this induced EMF is such that it opposes the cause by virtue of which it is produced. So hence, if the applied magnetic field is in the upward direction, then the magnetic field developed by the induced EMF will be in the downward direction, and according to right hand palm rule, it will be in the clockwise direction in this case. Let dl is the elementary length and E is the electric field along the closed path. Then induced EMF generated along elementary length dl will be E dot dl. Hence the induced EMF generated along the closed path will be closed integral E dot dl. Let ds is the elementary area in bounded surface S. Then the magnetic flux linked with the elementary area ds will be B dot ds. So the total magnetic flux linked with the bounded surface S will be integral B dot ds. According to Faraday Law of Electromagnetic Induction, the magnitude of induced EMF is equal to time rate of change of magnetic flux passing through the bounded surface enclosed by that path. Hence this law in integral form can be written as induced EMF along closed path is closed integral E dot dl, and the time rate of change of magnetic flux passing through the bounded surface is given by minus d phi b by dt, which in integral form is minus integral B dot ds. Negative sign represents